The Earth. As far as we know, it's the only home to life in the universe. So what makes our planet so special? To find answers, we must travel back in time. See the first humans walk the Earth. Ride each colliding continent. Face killer dinosaurs. Dive into oceans full of bizarre life forms. Feel the bitter chill of global ice ages. And experience the fury of cosmic missile attacks. By traveling back in time, we can piece together our planet's incredible story and discover why all of this and all of us are here. The journey starts almost 5 billion years ago. There's no sign of Earth just yet. Only the sun, a newborn star surrounded by dust. The Earth hasn't formed yet. But through time, gravity pulls the dust into tiny rocks. To our surprise, something as complex as a planet is made from nothing more than dust and rocks. Over millions of years, gravity pulls these rocks together to form the Earth. One of at least 100 planets circling the sun. But 4.5 billion years ago, Earth looks more like hell than home. Up close, the temperature is over 2,000 degrees Fahrenheit. There's no air, just carbon dioxide, nitrogen, and water vapor. It's so hot and toxic that if we got any closer, we'd be incinerated and suffocated in seconds. This newborn planet is a boiling ball of liquid rock. An endless ocean of lava. A young planet called Theia is heading straight for Earth. The size of Mars, it travels nearly 10 miles per second, 20 times faster than a bullet. The intruder's gravity distorts the Earth's surface. the blast wave races around the planet. It's as though both young planets turn to liquid. Trillions of tons of debris blast out into space. But over the course of 1,000 years, gravity turns the rubble into a ring of red-hot dust and rock that circles the Earth. From this ring, a ball forms, over 2,000 miles wide. It's the birth of our moon. But it's much closer than the moon today. Just 14,000 miles away, instead of 250,000 miles. The sun rises over a cooling Earth and sets just 3 hours later. The Earth is spinning so fast that an entire day lasts 6 hours. The days may pass quickly, but the Earth changes slowly. To understand the making of our planet, we need to fast forward through millions of years. $3.9 billion years ago, a hail of meteors attacked the Earth. It's debris left over from the solar system's formation. Inside the meteors are crystals that look like grains of salt. And inside the crystals are minute droplets of water. These deadly missiles could contain the vital ingredient for life on Earth. Only a small amount of water exists inside each meteorite. But as they bombard the Earth for over 20 million years, pools of water grow. The Earth's core remains molten, but its surface has cooled enough to form a crust. The air is around 170 degrees. In the future, there's a chance we could swallow this very water. Every sip, every puddle, every drop of water in every ocean is billions of years old. And it may have traveled millions of miles to reach us, carried inside a meteor. The Earth looks more familiar, but it's still a dangerous place. Winds are faster than the most destructive hurricanes today. It's a megastorm, whipped up by the planet's rapid rotation. The moon is so close to Earth that its gravity is overwhelmed, creating huge tides that race across the planet's surface. But over time, the moon moves away, the waves calm down, and the planet spins slower. "700 million years after the planet's birth, life-giving water covers its surface. And scattered throughout are tiny islands. They seem to have appeared from nowhere. So how did they get here? Molten rock bursts through the Earth's crust and rises up through the ocean. Over time, the lava cools, forming a volcanic island. In the future, these islands will join together to form the first continents. Earth now has water and land. It's beginning to look like the planet we call home. But the atmosphere is still toxic, and the temperature is scorching. Life here is impossible. Since the planet's formation, meteors have been pummeling Earth. But now, 3.8 billion years ago, the assault enters a violent new phase. Some things disturb the orbits of these meteorites. In addition to water, the meteors carry something else. As they dissolve, the meteorites release minerals. Carbon and primitive proteins made of amino acids are transported from outer space to the bottom of the ocean. Thousands of feet below the waves, it is dark and close to freezing. But a dramatic illusion is taking shape. Underwater chimneys spewing hot liquid. Seawater seeps down into the Earth through cracks in the crust, collecting minerals and gases along the way. This potent mixture is released back out into the ocean, building these towers. Combined with the minerals and chemicals from the meteorites, the water becomes a chemical soup. It's impossible to know how or when, but somehow these chemicals come together to create life. The water is now full of microscopic organisms. These single-celled bacteria are the earliest forms of life on Earth. This is a defining moment in the making of the planet. microscopic life is underway. For hundreds of millions of years, nothing changes. The only life is single-celled bacteria. To find more complex life, we need to fast forward to 3.5 billion years ago. And a shallow ocean. These look like rocks, or even plants, growing out of the seabed. Each mound is a colony of living bacteria called a stromatolite. These bacteria turn sunlight into food, a process called photosynthesis. It uses the power of sunlight to transform carbon dioxide and water into glucose, a simple form of sugar. And this magical transformation releases a byproduct, a gas called oxygen. Underwater, the stromatolites slowly fill the oceans with oxygen. The oxygen then turns traces of iron into rust, which fall to the ocean floor to form deposits of iron-rich rock. It's this mineral that will one day be used to build bridges, ships, and skyscrapers. Above the waves, the oxygen transforms the atmosphere. These stromatolites are creating the most important element for life on Earth. Without them, virtually every living thing wouldn't exist. Over the next 2 billion years, oxygen levels continue to rise. And as the planet's spin slows, the days get longer, lasting at least 16 hours. "3 billion years after the planet's birth, there's still no complex life. No plants, no dinosaurs, no humans. But the Earth has something unlike any other planet in this solar system. A force with the power to change everything. $1.5 billion years ago, the Earth is a beautiful blue ball, dotted with volcanic islands. Over millions of years, a mysterious force rearranges these islands. Hidden beneath the ocean, the Earth's crust breaks into vast plates. But even deeper, the Earth's core is so hot that it generates movement in the rock beneath the crust. These movements push and pull the plates around the globe, carrying the oceans and islands with them. Millions of years race by. Our planet is alive and changing. Over 400 million years, a vast new supercontinent takes shape. It's called Rodinia. In the shallow waters surrounding Rodinia, stromatolites work their magic for more than 2 billion years, pumping oxygen into the atmosphere. The temperature is 85 degrees, and the days are 18 hours long. But this planet looks more like Mars than Earth. To find life, we must fast forward through time. Washington State, 750 million years ago. A force deep inside the planet rips the crust to pieces. It's as though the world is breaking apart. And there's only one force powerful enough to do this: heat. It escapes from the Earth's molten core, stretching and weakening the crust. Inch by inch, year by year, the great supercontinent is splitting in two. The intense geological activity spawns a mass of volcanoes. They pump carbon dioxide into the atmosphere. The carbon dioxide mixes with water and creates acid rain. When the continent tore apart, many rocks were exposed. These rocks absorbed the acid rain, including its carbon dioxide. Vast quantities of CO2 are absorbed out of the atmosphere. Now, there's not enough carbon dioxide in the air to trap the sun's heat around the planet. In just a few thousand years, the temperature plummets to around -60 degrees. This frozen wasteland is southern Australia, 650 million years ago. It's the start of what some scientists call Snowball Earth, a period they believe to be the longest, coldest ice age ever to grip the planet. A vast wall of ice looms thousands of feet high. And it's unstoppable. The more ice there is, the more sunlight it reflects away from the planet, and the faster the ice spreads. Nearby is a second ice sheet, just as high. The two sheets spread away from the poles toward each other to meet at the equator. Now, an ice sheet up to 10,000 feet thick covers the entire planet. Earth first began as a molten ball of fire. Now it's a frozen ball of ice. Virtually all the sun's light and warmth reflects back into space. And it seems as though nothing, not even the sun, can rescue the planet now. $650 million years ago, ice entombs the planet. For 15 million years, the Earth is a vast frozen snowball. But it can't last forever. Something must release the Earth from this frozen prison. And when it does, who knows whether life has survived beneath the ice? The surface is frozen, but the core is still hotter than the sun's surface. Volcanoes have been erupting since the world began to freeze. But up until now, even their heat and power made no impact on the ice. Volcanoes pump out billions of tons of carbon dioxide. Before the Big Freeze, the Earth's rocks absorbed most of the CO2. But now, with the rocks smothered in ice, there's nothing to absorb the gas, so it fills the atmosphere. Like a blanket, it traps the sun's warmth around the planet, allowing the temperatures to rise. Now, after 15 million years, the ice begins to melt. It's thought that during Snowball Earth, the ice pushed the crust down. But now, as it melts, the crust bounces up, creating fissures and weak spots, and more volcanoes. The volcanoes release more carbon dioxide and push the temperature up even higher. The melt gathers momentum, and oxygen levels rise. Through a series of chemical reactions, the ice has created oxygen. While the planet was frozen, the sun's ultraviolet rays reacted with water molecules in the ice to produce hydrogen peroxide, a chemical rich in oxygen. Now, as the ice melts, the hydrogen peroxide breaks down and releases massive amounts of oxygen. The Earth is waking up, and it's a very different place. 600 million years ago, the atmosphere is warmer, like a summer day. And the days are about 22 hours long. Add all this water, and it's the perfect recipe for life. Before Snowball Earth, primitive bacteria emerged in the oceans. But surely they couldn't have survived an ice age 75 times longer than the entire span of human history. If something has survived, then life may be found where it was last seen, in the oceans. Now, 540 million years ago, in an ocean full of oxygen, those primitive bacteria have evolved. A handful must have clung on through the big freeze. There are plants scattered on the seafloor. And something else. What looks like an armored slug takes up residence. It's called Wiwaxia, a new generation of complex multi-celled organisms. The Earth enters one of the most dynamic periods in its history, the Cambrian explosion. Increased oxygen levels allow creatures to grow larger and develop bony skeletons. There are worms, sponges, and these trilobites, distant relatives of insects, lobsters, even scorpions. Life in the oceans blossoms. From microscopic bacteria to monsters. This is Anomalocaris. Nearly 2 feet long. It has large eyes, razor-sharp teeth, and grasping limbs. All it has to do is take its pick. The trilobite can't right itself. Its soft belly is exposed. Also found in the sea is Pichia, only 1.5 inches long. They may be the first organism with a spine. Over millions of years, this simple structure will evolve into the spine that keeps us standing. Expecting to find life in ruins, the oceans are in fact full of life. Where trilobites scavenge, monsters prowl, and where creatures begin to take on familiar forms. Beneath the waves, there are already tens of thousands of plant and animal species. The advance of life seems unstoppable. 460 million years ago, the plates had been moving again. A new continent now exists, Gondwana. It's 90 degrees and oxygen levels are close to what they are today. The land should be covered with plants and crawling with creatures. But there's not much here, besides a few patches of algae. There's only one explanation. The sun. It blasts the surface with deadly radiation. So the complex life in the ocean doesn't stand a chance on land. But 30 miles up, where the rays enter the Earth's atmosphere, something is happening. When oxygen meets the sun's radiation, it turns into another kind of gas called ozone. This gas forms a blanket around the planet and absorbs the lethal radiation. Over 120 million years, the ozone layer gets thicker and prevents more and more radiation from reaching the Earth's surface. Without this layer, life on land simply wouldn't exist. Now, shielded from radiation, life takes off. Small, mossy lumps are the first land plants. They pump out even more oxygen. Levels soar. $375 million years ago, a new species lives in the water. Swimming. It's a strange fish called Tiktaalik. It uses its neck to raise itself up. And its fins function as legs, allowing it to move out of the water. This is one of the most important moments in the making of our planet. Over 15 million years, creatures like these evolve. They grow stronger limbs and spend more time out of the water, where plant life is exploding. Until 360 million years ago, their relatives, called tetrapods, make the land their home. From tetrapods, four-legged vertebrates evolve into dinosaurs, birds, mammals, and eventually, humans. There are mosses and ferns everywhere, some at least 100 feet tall. A seed is carried by the wind. Until now, plants reproduced using spores, single-cell particles that need plenty of water to grow. But this seed is miles from water. This embryonic plant has its own food and water supply. Unlike a spore, this seed can survive far from water for months, even years. The humble seed spreads life across the planet, and each tree and plant pumps out even more oxygen. It's an environment very much like today. The planet has come a long way, from a lump of burning rock and dust to a blue and green world bursting with life. There are now fish, plants, and this. The dragonfly. It's called Meganeura. This insect is the size of an eagle. What were once legs have evolved into wings, extending the dragonfly's hunting territory over a vast area. There are also millipedes and spiders down there. These creatures, called arthropods, were among the first to set foot on land hundreds of millions of years ago. They look almost identical to the bugs that invade our homes today, except for one big difference. Like the Meganeura, they're monsters. It's a world full of giants, where millipedes are 6 feet long, and scorpions are the size of wolves. This is because the oxygen level is much higher than it is today, which allows their respiratory systems to be more efficient, fueling their bodies to grow larger. So far, animals have been laying their eggs in the water. But a lizard-like creature, called the Hylonomus, prefers land. Its eggs contain all the water and nutrients that the developing fetus needs. The babies grow in their own self-contained pond. The egg is a major evolutionary breakthrough, allowing animals to leave the water behind and conquer land. This baby Hylonomus leads the advance. As a new creature, the reptile. Inevitably, with life comes death. Dead plant matter builds up and decays into dense, soggy layers. Over hundreds of millions of years, rocks cover these layers, and heat from the Earth's core and pressure from the overlying rocks transform these layers into seams of coal. Each lump of coal burned today is made of plants that died 300 million years ago. Amidst the decay, hidden from sight, life is stirring. Soon, seeds will germinate, plants will grow, and this wasteland will live again. Life seems to have conquered the planet. But will it last? A herd of creatures graze the Siberian plains. And they are big. Evolution takes a huge leap forward. Small lizards are now giant reptiles. These scutosaurs are distant relatives of turtles. If these plant eaters look tough, the carnivores must be seriously mean. Like this Gorgonopsid, a perfectly engineered prehistoric killing machine. The Gorgonopsid's saber teeth wound the scutosaur. The predator watches as its prey grows weak from blood loss. But before it can make its final move, something strange happens. The ground gets hot. Enormous pressure builds beneath the surface, and lava spews into the air. But the lava isn't from one single volcano. The entire landscape is erupting. It's a flood basalt eruption. A massive plume of mantle rises up from deep inside the Earth and pushes molten rock out through fissures in the Earth's crust. The lush paradise is now a lifeless hell. The scutosaurs and the Gorgonopsids are dead. They're the first casualties in the greatest mass extinction the world has ever seen, the Permian extinction. On the other side of the continent Gondwana, nothing's changed. Yet. It appears to be snowing, but the temperature is about 70 degrees. It's actually ash, fallout from the eruptions some 10,000 miles away. The ash burns and suffocates the animals, killing them around the world. Sulfur dioxide from the eruptions fills the atmosphere. As it rains, the gas turns to sulfuric acid and burns everything it falls on. What was a local disaster has now turned global. The Siberian eruptions increase the Earth's carbon dioxide levels. The atmosphere gets hotter. Water evaporates. And vegetation dies. Around the world, life on land is being wiped out. And life in the oceans has also been compromised. The waters turn pink. Plants, trilobites, and predators disappear. The new, hotter atmosphere heated the oceans and stripped them of oxygen. Now this pink algae is one of the few life forms that can survive in the stagnant water. The Siberian eruptions transformed the entire planet. Nothing, not even the deepest ocean floor, is beyond their reach. Bubbles of methane gas escape from beneath the seabed. Methane is a greenhouse gas, at least 20 times deadlier than carbon dioxide. Until now, the gas has been frozen, but as the sea temperature rises, it begins to melt. Released into the atmosphere, this powerful gas pushes up temperatures even further. It's now almost 105 degrees, 11 degrees hotter than before the Siberian eruptions. Creatures that survive the initial destruction now face a new and deadly environment. Few will live. It's been 500,000 years since the eruptions first began, and all this time, the lava's been pouring out. By now, it covers an area the size of the United States, with a layer of molten rock nearly 4 miles deep. "95% of the species are gone. A few survive by eating anything they can find and living in burrows underground. But everything else is dead. 250 million years ago, the Earth reverts back to an almost lifeless planet. But that's about to change again. It's been 50 million years since virtually all life on Earth was wiped out. And the planet has been transformed. It's now 200 million years ago, and just one supercontinent, Pangaea, stretches from pole to pole. After the trauma of the mass extinction, the planet heals. Temperatures stabilize. The acid rain neutralizes and vegetation returns. With 95% of all life on Earth wiped out, the field opens for a new species to emerge. One that will dominate the planet like no other. The dinosaurs. These are called amosaurs. Like all dinos, they evolved from the reptiles that survived the Permian extinction. At 15 feet tall, their size makes them slow and vulnerable. Nearby is the Dilophosaurus. It's small and fast. The Amosaurus is too big a meal for one Dilophosaurus, but not for two. The dinosaurs have repopulated the Earth, but no species can tame this restless, volatile planet. The Earth's crust is thinning. It's releasing lava and shaking with earthquakes, as if being stretched by some unseen force. It's also happening near what will become North America's eastern seaboard. The Earth's plates are on the move again. 190 million years ago, the great supercontinent of Pangaea tears apart. A vast slab of land breaks away, creating a chasm. It fills with a new ocean called the Tethys, over what will one day be the Middle East. Currents push nutrients up into the coastal waters. And the nutrients attract fish in the millions. But again, with so much life, also comes death. Dead fish and plankton carpet the ocean floor. Over the next 10 million years, layers of rock will bury and heat the dead creatures. Ancient fish and plankton will become oil. Every gallon of gas in our cars, every piece of plastic on the planet, the paint on our walls, the carpet under our feet, even the soap we wash with, almost all originated in this way. "180 million years ago, the North American plate is still moving away from the European and Asian plate. It's shifting about 1 inch each year, the same speed at which our fingernails grow. But fast forward 35 million years, and a new ocean forms, as well as new continents. The United States breaks away from Africa. The world as we know it takes shape. The chasm between the two continents fills, creating the Atlantic Ocean. And in the middle lies a volcano. Like before, currents deep beneath the Earth's crust move the plates again. The entire seafloor tears in two and is pushed up into a ridge of mountains and volcanoes. It grows higher than the Himalayas and longer than the Rockies. The water here is hot, as molten lava forces its way out from deep inside the Earth. As the lava cools, it creates a new range of volcanic mountains and a new ocean floor. Pangaea breaks apart, and our world rearranges again. It's this geological activity that makes the Earth restless, creative, and unique. And every time the planet reinvents itself, its inhabitants adapt and evolve. Like the ichthyosaurs. Their reptile ancestors lived on land, but as the planet changed, so did these animals. They grew fins and moved into the newly formed Atlantic Ocean. This one is 20 feet long and can travel at a quick 25 miles an hour. It's the ocean's fastest creature and most efficient predator. It rules the oceans for 50 million years. But now, there's a new contender. Pliosaur. Longer than a bus and as heavy as a truck, its jaws are 8 times more powerful than a great white shark's, with teeth 12 inches long. The Earth and its inhabitants have changed beyond recognition. This was once solid ground. Now it's the Atlantic Ocean. The very spot where Ammosaurs grazed and Dilophosaurs stalked their prey. The dinosaurs' world may be different, but they're as dominant as ever. They appear invincible. They're one of the planet's most successful species. They've survived volcanic eruptions, Earthquakes and entire continents splitting apart. The dinosaurs have thrived for 165 million years. A number of mammals have also survived, like this shrew-like animal. They're prey to the dinosaurs, so they live in trees or underground and venture out only at night. Mammals pose no threat to the dinosaurs. Nothing on Earth can challenge their dominance. Nothing on Earth. A large piece of space rock heads toward Earth. This asteroid is at least 6 miles across and traveling over 40,000 miles an hour. It's bigger than Mount Everest. And heads straight for the Gulf of Mexico. It travels so fast that its impact would be missed in a blink of an eye. A split second changes the world forever. At impact, the asteroid's back edge stands at 35,000 feet. It strikes with such immense force that it destroys everything it hits. The asteroid itself instantly vaporizes. Unleashing the energy of millions of nuclear weapons. Nowhere is safe, with debris flying everywhere. Debris as big as entire city blocks circle the Earth. The blast wave races out from the impact zone like shrapnel from an exploding bomb. Minutes after impact, hundreds of miles from where the asteroid struck, the Earth is under attack. Boulders rain down. Earthquakes shake the ground. and tsunamis batter the coasts. But the onslaught has only just begun. The plume of molten rock and dust spreads out and engulfs the planet. The entire sky acts like a giant lamp. Heating the Earth's surface to over 500 degrees. Vegetation spontaneously ignites. Even months after the impact, smoke and ash still block out the sun's rays. And with less sunlight, plants die and the animals starve. "65 million years ago, the impact has blasted, stoned, and burnt the dinosaurs. Their 165 million year reign is over. But the dinosaurs' demise brings opportunity for another species. A mammal. By living underground, mammals have avoided the heat and fires. And by eating anything, they thrive while more selective eaters die. They're the unlikely inheritors of the dinosaurs' crown. And as one story ends, another begins. With the dinosaurs out of the way, our ancestors may now have a chance at life. The dinosaurs are long dead. The planet is peaceful. In this new world, our mammal ancestors are evolving. "47 million years ago, this lake, in what will one day be Germany, is the perfect place to spot them." Unlike earlier mammals, its eyes and brain are bigger. This is Darwinius massilae, or Ida. She looks nothing like humans, but fossil evidence today indicates that these creatures might evolve into monkeys, apes, and eventually humans. Looking back through 47 million years of evolution might reveal one of our earliest known ancestors. The lake sits on a volcanic crater. It belches out noxious gas that eventually kills Ida. The lake preserves her in its oxygen-depleted depths. One day, when the water is gone and Ida's fossil is found, this primitive primate could help piece together the beginning of our own story, the story of human life. We're closer to understanding how everything we've seen, from ocean bacteria through walking fish and subterranean rodents, leads to us. And to understanding how our planet was made. 47 million years ago, the atmosphere is much like today. The temperature is 75 degrees, and the day lasts just under 24 hours. The Earth is now almost identical to the planet we call home. Almost. The Earth's plates are on the move again. India moves north toward Asia. The Indian and Asian plates are locked in a titanic struggle. Neither plate is winning. As they buckle, the ocean floor contorts upward along a 1,500-mile line. A vast mountain range rises up over 27,000 feet. These are the Himalayas. And the highest mountain of all, Mount Everest. Its summit reaches up into the Earth's jet stream, the same altitude where planes fly. When the snow on the peaks melts, it feeds rivers like the Ganges, Indus, Yellow, and Yangtze. The Himalayas are like a vast water tower. One day, their rivers will supply water for almost half the world's population. "20 million years ago, this is our planet. With every continent and every ocean as we know it. Except one thing is still missing: the human race. And for humans to evolve, something needs to change. Along the African coast, a great rift opens up. It stretches nearly 4,000 miles. With mountains growing along its edge. This ape-like creature may stay in these trees forever, but its world is changing. The growing mountains act like a wall, prohibiting moisture from the Indian Ocean from passing over the land. It's getting hotter and drier. The lush rainforest becomes an arid savanna. The new, hotter climate changes the creatures' habitat, forcing them to search further for food. Soon, they stop dragging their knuckles like apes and begin to stand and walk on 2 feet. It's the most important step in the human story. This mountain range could be the reason humans walk on 2 feet. The random movement of 2 plates may have kick-started a chain of events that leads to the first humans. A man and child, a scene very much like today, but it's 1.5 million years ago. They are an early species of human called Homo erectus. And these are the first footprints like our own. Civilizations past and present. Everyone that's ever lived. The greatest inventions, the most brilliant ideas, human history in all its complexity and splendor begins here and now. The climate changes again. 70,000 years ago, sea levels fall, and the gap between Africa and Arabia shrinks to just 8 miles. The Red Sea is now narrow and shallow enough for a small group to cross out of Africa. They're another later species of human called Homo sapiens. Scientists believe that the entire world beyond Africa was populated from descendants of these 200 individuals. Over time, our ancestors multiplied and spread out to India, onto Asia, and into Europe. But while humans head north, a giant wall of ice travels south. Europe, 40,000 years ago. Homo sapiens arrive, only to find a world that's quickly changing. It should be the height of summer, but it's getting colder. The plants are frostbitten, and the rivers are frozen. Natural changes in the Earth's orbit, CO2 levels, and the flow of warm water around the planet conspire to lower the Earth's temperature. The Earth and its inhabitants enter an ice age. Glaciers as high as skyscrapers creep over the northern hemisphere about a foot every day. Slow and powerful, they sculpt the landscape, gouging out great depressions. The planet will never look the same again. Now, around 20,000 years ago, they grind to a halt. Much of the northern hemisphere is covered by ice sheets up to 1.5 miles thick. With trillions of gallons of water locked up as ice, sea levels fall. A strip of land emerges from the ocean between Siberia and Alaska. It's a bridge between two vast continents. A gateway that takes humans from Asia to a new world, the Americas. They're the last great continents to be colonized, the last great human migration, and the first Americans. Now, 14,000 years ago, the changes that triggered the Ice Age reverse. As the ice retreats, it reveals a very different northern hemisphere. The huge depressions that the glaciers create fill with water to become North America's Great Lakes. "6,000 years ago, the ice retreats back to the poles, toward the Arctic and Antarctic. After a 4.5 billion year journey, we're finally home. This is our world, our time. The planet's incredible story helps us understand how and why everything around us is here today. From the skies above to water, the essential ingredient for life, to the ground beneath our feet, and finally, life. A chain of catastrophes and coincidences, creating a spectacular result. Each triumph and disaster is a step leading to here. To each and every one of us, right now. But the Earth's story isn't over. This journey is only half the story. A lot more is yet to come. The Earth will live for at least another 4.5 billion years. More wonders, more terrors, and more strange creatures lie ahead for our restless and creative planet. The next chapter of Earth's story is still to be written.